Examiner, and you're welcome viewers at home. My name is Lincoln Examiner, and you're welcome to Akimo's Educational Online Services. And today we are treating meter bridge in physics, and the topic is electricity. And now we want to find out how we can use the meter bridge to measure resistances of materials, because the voltmeter ammeter method is not very accurate because of the zero error in the galvanometer and the ammeter respectively. So the meter bridge gives you a better method of measuring resistances of materials. Now, what you have on the board is the diagram of a meter bridge, a typical example of a Wheatstone bridge, which measures resistances of materials. Now, it runs from this end to that end with a meter roll attached to it with a resistance wire, which runs on the meter bridge, of which is graduated in centimeters. From one end A to the end B is 100 centimeters, which is equivalent of 1 meter. Now, we can say that X over R, numerically, X over R is the same thing as L1 over L2. That is the rule, the principle governing the meter bridge. Now, if you cross multiply this expression, and in case this is known and this is not known, we want to find R. If our R is equals to 10 ohms, and our L1 is equals to 20 centimeters, definitely our L2 will be equals to 80 centimeters. That means that we can find X in this case. Now, if we substitute that into this equation, we have X over R1 is 10 is equals to L1 over L1 is, the value for L1 is 20 centimeters, just like 20 there. And then under it, we write 80. Now, we must cross multiply this. If we cross multiply, we have 80x is the same thing as 20 times 10, which is equivalent of 200. Now, the value for x alone, from this equation, the value for x alone will give you 200 divided by 80. And if you cancel this, you have 0 cancel 0, 4 can go here, 4 go here, 2, 4 go here, 5. You have 5 over 2, which is equivalent of 2.5, which is equivalent of 2.5 ohms. So the value for X in this arrangement is 2.5 ohms. Now, that leads us to the end of the meter bridge, and we are going to look at electrical consumption, application of electrical consumption. What we call the NEPA bill. How does NEPA pay their bill? NEPA bill. How does the bill work? Every month, NEPA will come to us and ask you to pay their bill. How do they calculate their bills? Now, the principle is this. Now, NEPA bill says that 1 kilowatts, the watts seconds is equal to 1 joule. Now, when you have a number of appliances you use in the house, and this gives you the each of these appliances is rated in, because the power at the mains is 240 volts. Now, let's take a typical example. A lamp is rated, an electric lamp is rated 20 watts and 240 volts. What does that mean? It means that the power consumed by the lamp is 20 watts, whereas the power and the voltage on the mains is 240 volts. That's what it means. Wherever every electrical appliance you pick up, the power is rated there. The power consumed in this case is 20 watts, and the voltage at the mains, at the socket, is 240 volts. Now, the question is, how much current does this electric lamp consume? How much current? Does this particular lamp consume? Now, what that means is that it says P is equals to IV. Power is generally defined as equals to P is equals to IV, where I is current in amperes and V is voltage in volts. Now, with this arrangement, W power is 20 watts given in the question, and the voltage is 240 volts. 240 volts. Now, that is the voltage times I. The voltage is here times I. And we want to find the current in which this particular lamp consumes. Therefore, we make I the subject of the formula. Therefore, our I is equals to 20 over 240. 240. 0 cancels 0. And we have 2 over, which is 1 over 12. This is 1 over 12. This amount in amperes will give you the current the lamp will consume, which is equivalent of 0. You can now divide that. Use long division to do that division. It's very simple. 12, 1 is in there and 12 is here. This goes into this, cannot put 0 and add a point. This goes into there, cannot again add 12 into 10 is not possible. Add 0 and put the mark there. And that will be about 12 times 9. 12 times 9 is what? This is 18, carry 1. 9 times 1, 9 plus 1 is more than 12 times 8. Let's use 8 this time. 12 into 8. This is 16, carry 1. That's 96. That's about 96. And now if you subtract that properly, this you have 4 remaining. Now, when you add 0 to that one, give you, this was 8. And then you add 8, 12 times 8 will give you I, the subject of the formula. Therefore, I is equals to 20 divided by 240 amperes. This is equals to 1 over 12, which is equal to 0.0833 amperes. That's the current that flows in the lamp. That's how much the lamp can consume, and the power is 20 watts, while the voltage that it means is 240, and that lamp can take a current of about 0.0833 amperes. Now we are going to look at the I need to draw this.
We need to draw.
I need to draw some.
Okay.
We have finished the first question, and this second question centers on potentiometer, and this is a practical application of a potentiometer. The length, as you can see, is still the length of 100 centimeter. That's equivalent of 1 meter, a meter rule. Now, a potentiometer is a device used in comparing the electromotive force of two cells. In case you know the electromotive force of one cell, you can use a potentiometer to determine the electromotive force of the second cell by this arrangement. This is a typical example. A potentiometer wire carries a steady current
Okay.
Now we finished that other example. This one we are focusing on potentiometer. Like I told you earlier, potentiometer provides an accurate means of comparing the EMF of two cells. And this is a practical example. A potential wire carrying a steady current is 1 meter long with a standard cell of EMF of 1.02 volts. Suitably connected, a balanced length of 63 centimeters was obtained. What is the EMF of a cell which gives a balanced length of 84 centimeters? Now we are going to solve that problem using the principle of potentiometer. And it says that E1 over E2, the same thing as L1 over L2. This is the ratio that compares the electromotive force of one cell and the other and the equivalent length as it is written on this board. Now let's put that in practice. Our E1 here is 1.02. And our E2 is unknown. Is what we are looking for. Now L1 from the board, the first length talks about the length of E1, which is 63 centimeters. And the L2 is that of cell 2, which is 84 centimeters. And now you cross multiply so that you make E2 the subject of the formula. Once this is done, you have E2 into 63 is equals to 1.02 into 84. Now, the value of E2 could be found by saying 1.02 times 84 divided by 63. And if you punch that properly, you have 1.36 volts as the electromotive force of the unknown cell, which is E2. And this is the method used in finding the electromotive force of unknown cells. I think we have come to the end of this class. And then you can copy your notes in Akimos platform. See you in next edition. Thank you. And this is another practical application of the potentiometer. Two standard resistors of 2 ohms and 3 ohms respectively are used in meter bridge circuit. At what point on the bridge wire must the balance point be? Now what that means is that we have two resistors in this arrangement with a driving cell of electromotive force E, and the length from this place to this place is L. Since the whole length is 1 meter, this side will give you 100 minus L to give you a total length of 1 meter, which is equivalent of 100 centimeters. Now look at how it is applied here. L over 2. L over 2 is equivalent to 100 minus L over 3, because we are comparing two resistors and then we are looking for a balance point now, because the application is that at null point there should be no current in the galvanometer. That means the place is balanced. That is an accurate means of measuring the resistance of a potentiometer. Now you cross multiply this. Once you cross multiply this, you have 3L is equals to 2 into 100 minus L. Now 3L is equals to 200 minus 2L. Now you collect like terms. Once you collect like terms, you have 3L. When this minus 2 crosses equality sign to this side, it becomes plus 2L, and that's equals to 200. Now 3L plus 2L is 5L because they are like terms, and this is equivalent to 200. We make L the subject of the formula. Therefore, the value of L alone will give you 200 divided by 5. 5 cancel itself 1 and cancel 40 times. And that gives you 40 centimeters. That is the value for L. That is the point in which the balance point must be. And in fact, that gives us the point which the calculator makes no further reading, because at null point, no current will be in the galvanometer. And that is the end of this lesson. And I wish you to copy your notes in Akimo's homepage. Stay safe and see you in next edition. God bless you.